Okay, we're going to be doing lead code 1855, maximum distance between a pair of values. So you're given two non-increasing, which means decreasing, zero indexed integer arrays, nums1 and nums2, a pair of indices I and j, where I is within the possible indices of length nums1 and j is within the possible indices of nums2, is valid if both I is less than or equal to j and the value at I is less than or equal to the value at j. The distance of the pair is j minus I, right? So you're supposed to return the maximum distance of any valid pair I and j. If there are no valid pairs, return 0, right? An array is non-decreasing if, okay, yeah, this is self-explanatory. So essentially, the first thing we can do is to brute force, right? Iterate through nums1, and for each index of nums1, let's do that here. So we have a max distance, which we set to 0, and then we iterate through for I in range, length of nums1, and then for j in range, length of nums2, right? Oh, sorry. Length of nums2. We check for our condition. And what's our condition? If I is less than or equal to j and nums1 at I is less than or equal to nums2 at j, right? Then we have found valid points. So we update our max distance. So our max distance is equal to max of max distance and j minus I, right? Because j is supposed to be greater than or equal to. If we come here, then we haven't found anything, so we return 0, right? But this is a brute force solution, right? Nums2, nums1 at I. Well, this is supposed to work. Output is 0, expected 2. Must have made a mistake somewhere. If I is less than or equal to j and nums1 at I is less than, max distance is equal to max distance j minus I. Well, the initial one that I did, let me see. I had a time limit exceeded version. Local max. Well, this was it. Return max. Oh, my bad. I just made a mistake. This is supposed to be return max distance. Sorry about that. Yeah, you see, it works. But we can do this in n time. This is brute force, so it will give us a time limit exceeded. But we can do this in O of n, length of nums plus length of nums2. We'll call it O of m plus n. And the way we do this is we have pointers starting at 0 and 0, right? So actually, let me draw it here. Right. Hold on a second. We'll have pointers. So let's say that's our first. Let's say this is our nums1, and our nums2 is 100, 20, 10, 10. Right? The thing is, the possible search space is going to be all indices of I that are less than, right, or equal to indices of j, right? This is the search space we want for these, right? And then the other thing is the values in the search space. So that means any index in nums2 that is greater than, we don't want to consider it. So essentially our search space is the length, the combined length of the smaller one, right? The combined length of the smaller one. So which means we'll be iterating from I less than length of nums1 and j less than length of nums2. And what we'll focus on is that we'll focus on the values. Since we know our search space is this, we focus on the values. We don't focus on the indices. We focus on the value portion because our while loop deals with the possible search space, right? So let's code it up so that you get what I'm saying. So our I is equal to 0 for nums1, our j is equal to 0 for nums2, our max distance is equal to 0 for now. So our while loop is while I is less than length of nums1 and j is less than length of nums2, because this is our possible search space, right? The length of the smaller one is our possible search space, right? So now we check for our value condition, because this satisfies index condition I has to be less than or equal to j, right? So we check for a value condition nums at I less than or equal to nums at j, right? So if nums at I is less than or equal to nums at j, then we have found the point, valid values, right? So we update our max distance. Our max distance, which will be max distance is equal to max of max distance and j minus I, right? Then after we've done this, we update our j pointer, right? So j plus equals 1. Why not I? Not I because we still need to find values. There may be other values of j which are less than, which are larger than I, that we need to find compared to this I pointer, right? Else, this simply means nums at I is greater than nums at j. So we want to move closer to the condition. And how do we do that? We say I plus equals 1, right? And here we simply return max distance, because this is going to iterate through one at a time from this and this, right? So this should give us our answer. If nums at, oh, I said nums, so it should be nums1 and nums2. It should be nums1 and nums2. Simply means, okay. And that is our solution. This is a 2-pointer solution, not binary search. 2 pointers solution. So yeah, So for this condition, I is less than or equal to j is satisfied by this. And then we simply have to check for this, right? Yeah. Another way of writing this is if nums at I is greater than nums at j, then we simply increment our I, right? So we say I plus equals 1, right? Because we're trying to get to a condition where nums at I is less than or equal. So else, we found our condition, i.e. nums at I is less than or equal to nums at j, right? So here we check max distance. Max distance is equal to max of max distance and j minus I, and then j plus equals 1. So this will also work. All right, forgot again, 1 and 2. Why do I keep on forgetting that? 1 and 2, okay. This will also work. So that is the solution, and it takes all of m plus n, where m is the length of nums1 and n is the length of nums2. All right, and the space complexity is O of 1. So that is the solution to 1855, and yes, so thank you and bye.